All right, folks, welcome to Module 5, the distributed package. I thought it'd be good to kick this one off with showing a little bit of the testing and code coverage. This really is a lot of why I like putting code in a distributed package. One is it's usually very highly testable. And look at this, we've got a total of 84% code coverage over the entire code base. We're missing some stuff on what looks like an abstract class and a result type object. So not a whole lot being missed. So this is pretty cool, and that means that I'm going to have a fairly good coverage of branches. So I have basically a risk of 16% when I distribute this code, but I've got an 84.6% that things are going to be in good shape when I change things. So code coverage is also another one of those topics that could be benched for another time, like what it actually means and how to interpret it and all that stuff. So not going to dive into that, but one of the important things is we took a look at the inference function and how it leveraged these capabilities in the package. And we're testing it in one location and being able to get a good view of what our coverage and code quality looks like in the continuous integration portion of its build. It also has a continuous release. Let's go ahead and pop this thing open. And something to actually do ahead of time. This is kind of important when building a distributed package. We're going to start off, now that we're working with the package itself, by uninstalling the package so that we can run local tests. So if I were to be working with a distributed package and I have that package installed and I'm making imports, it's going to default to the installed package and not the local package. So I need to start by pip uninstall AI ACC underscore quality. That's the package that we have. So we successfully uninstalled version 0.0.49. What's kind of cool is, let's check this guy out. Build number 494. 494. So there's some really nice things about having automation in places that I can match issues in specific versions of my packages all the way back to specific versions of my build down to a commit number. That's super cool. So with that, now we're working within the local package. We're using Visual Studio Code here. Big thing is testability. I'm a big fan of testing. So you'll see that we have breakdowns inside of here for what tests look like. And tests are really a good way to create documentation. So if I wanted to see the machine learning test prediction, this is what I should expect for prediction from a user's perspective. So they should create a classifier, load the classifier model. They should have a widget. Here we're generating a widget using a generator helper. This one's an anomaly. We want to make a prediction and assert that if that is good is false. What's cool here is that we have a small unit test using a real pattern that we validated is in fact an anomaly, and are making sure that this is a sanity check. It should totally predict that this one is in fact an anomaly. And then here, generate widget is anomaly equals false. We want to make sure that it also can handle the the normal case as well. So we're doing some quick sanity checks on the algorithm inside of our unit tests. That's kind of cool. And also, this is great documentation for how to actually use things. So big parts of testing. So let's take a look at how this thing is broken down. We have a source folder. So this helps with the packaging process. I can't remember the exact details about why I wanted to put it in an SRC folder, just that it helped with something and it was breaking for some reason. So I had to stick it in an SRC folder. Then I have the name of the package that's going to be created. So whatever I want the users to do a from blank import blank kind of statement, kind of like in our test, from AI ACC quality dot data models dot widget import widget. So inside of here, we have three big things that are being brought to the table. We have connectors, we have data models, and we have ML. I'll keep ML off for last. Inside of connectors, just one storage connector, and this is getting our database connection for SQL, it's getting our table connection, and it's getting our event hub. I've had some debates with people about this. The thing of the matter for me and why I decided to go this route was that I was just writing this code everywhere, and I was copying and pasting this block of code. If I find myself copy and pasting a block of code and a bunch of stuff, you bet I'm sticking that in something I'm distributing. Just end of story. Like, there are various other opinions, and we got into some debates about that, but if I'm copy and pasting it into multiple code bases, I'm going to not be doing that. I'm going to rip that out of all the code bases, put it in a distributed package. And here we're using, and it's nice because you can kind of standardize on things. Like, I want to make sure that I get everything in as a environment variable. So I expect environment variables for everything. So that's pretty cool. Those are connectors. We have data models. Now, this is a little bit more important to understand. This is where we have defined what the domain object looks like. If you're looking to use this solution for you, this is where some of your biggest changes are going to happen. So the widget class, for example, it has a serial number, a factory ID, a line ID, some telemetry, and a classification. Your stuff, you might not have a factory ID. Maybe you're in agriculture. Maybe it's a farm ID. Maybe in a farm, it's a plot number or a plot ID. I don't know much about agriculture. I guess I did a little bit of agriculture. We had like nursery locations within the globe. Then there was greenhouse number, and then there was like little subplot number. So you've got three different hierarchies there. So anyways, the main things that make up a widget, this is where you're going to put it. This is also where it has the to dictionary, to JSON, from dictionary, from JSON, the persisting to SQL, taking in a connection. So you could change the connection. If you change the connection type from, say, SQL to Mongo, you should be failing here. This is another reason I've kind of bound the interactions with the definitions of the objects, is that if I change a type of connection or a type of infrastructure, I have to change the connection. When I change the connection, that should break my unit test for persistence for that particular thing. It's another reason testing and having a distributed package that's easy to test is really, really nice. Things like this, generating a partition key. So you have to agree on a lot of these contracts, data contracts, text contracts, location contracts. What I've seen in a lot of other code bases is that they're individually placed in the various areas. So like the service that puts the record into the database has its own thing of generating a partition key, and then the web application that's trying to query for it has the same exact code twice. So if you guys encounter an issue where you need to change the schema for how you create a partition key, you have to change it in both places, and usually those people don't match up. I'm oftentimes the one doing both of them, and it's hard enough for me, much less introduce two people. So it's nice to be able to have this in a distributed package. From table, again, this is just grabbing it from the table. So I can persist to the table, I can get it from the table, I can persist to SQL. I don't actually have my select statements in here. I did put some of the select statements into the web application. There's reasons for that. I might have very specific queries that are more specific to the web application. So I don't necessarily need to do that. I should probably have at least a select like hydrate widget from SQL, so it's more of like a select one kind of thing, as opposed to the website is usually doing a select many kind of thing. So that's your widget. Then you have this widget classification. Now, going back to the machine learning section, we do not have a standard deviation distance, a standard deviation, a mean, or a threshold anymore. These really are going to go away. I just haven't taken the time to refactor the code base. But I'll have to delete all this and then make sure that the base package passes. Everything else that depends on the base package should be pegged to a specific package version. So if they're pegged to package 494, they'll be using this definition. If I make a new release and it upgrades to version 495, they can still use 494. That should be fine. I might want to add some unit tests as like regression type tests between 494 and 495 though. So some things to think about when handling one of these packages where people are taking dependencies on you is if you upgrade your package, you are likely to possibly break a bunch of your downstream consumers. But if you're binding your packages and updating version numbers, your minor version shouldn't have breaking changes. Your breaking versions should have more major version numbers. So I might change my my version number for when I introduce the upgraded version with a new algorithm to a 1.0 type format. So that's our widget. Now, one thing to know on our widget was the telemetry is a list of telemetry. So many telemetries, many samples comprise this. Let's take a look at that. So not a whole lot. It's 5 float values and a timestamp. That's it. And then it has some stuff around converting it to a dictionary, converting it to JSON from a dictionary, so forth and so on. So, you know, it controls its own conversion type functionality that, you know, so you don't have to repeat that code in other places. So those are the data models. So if you're building this for yourself, updating the data models will then, once you do that, be distributed to all of the services. So that's really handy. Now, before we jump into the machine learning capabilities of the distributed package, I want to make sure that we review this file here, download model.py. If you recall, I believe it was module 2 was our machine learning module. We had 2 Python notebooks that trained a neural autoencoder and a k-means cluster and had a variety of other assets associated with it. We persisted those inside of the model zoo. So we need to be able to download those models into a specific location. So what this file does, and it takes in some arguments, it wants the subscription ID, the resource group, the ML workspace name, or it's going to look for those in environment variables. And it's going to download that particular model into the source AI ACC quality ML assets folder. Now, it is important to note that the way that this is currently coded, it requires you to execute an AZ login. So let's go ahead and show you AZ login. If I do AZ login, there we go. Pops up a browser, asks me to log in with my corporate credentials. It says, thank you. So now I've logged in, pop this down, and it's going to show me which subscriptions I have access to, which is a lot. Here we go. So, you know, it shows me all these subscriptions that I have access to, and let's just not show you guys that. So I'm not using a service principal here. This is something that I, as a developer, am kind of controlling, because once I copy these files into this ML assets folder, I'm going to check those in and I'm going to begin version controlling those. So if you take a look at the GitHub ML assets and anomaly, I'm actually version controlling. The last time I updated the model itself was 9 days ago. So I'm baking the version into my standard version control system in this solution. So that's an important thing to know, that it works like this for this. Mileage may vary. Alternative approaches may need to be happening depending on, one, are you an internal solution or are you an ISV solution? And other factors around how you update, manage, maintain, what your DevOps lifecycle looks like for various people. You might split the distributed package into like a domain package with your domain models and your data connectors and all that stuff. And then you might have a machine learning distributed package. I made one package because I wanted to keep it simple for now. So once that happens, you get the AZ model. You want the anomaly encoder decoder. Because I'm not specifying tags here, it's just going to grab the latest one according to its version. And I'm just going to download to the target directory, which will drop here. Cool. So let's take a look at what this does. First, let's take a look at the interface that I'm expecting. Base algorithm. I want any algorithm, no matter what algorithm they implement, I want to make it easy for my users, so I defined a abstract class that everybody should be using. And it's super simple. You create an instance of the class, you load the model, and you can predict. I didn't want anything more than that. Whatever else is required to happen to actually execute a prediction should happen inside of that prediction function. Let's take a look at what that actually looks like. So this is our widget classifier. Notice here how we're using relative imports in the package, by the way. In this distributed package, initially I used absolute imports, but I ran into issues with Azure Functions. So in a lot of the cases, absolute imports work. If I can pip install this package, an absolute import is going to work. But if for some reason or another I can't pip install, in the case of Azure Functions or possibly some other platform that may have some kind of restrictions, maybe the PyPy index is located in a place behind a firewall I can't get access to, so I need to start copying code over, and I don't want to stand up an index just for that. There's a plethora of reasons of why this could be the case. The relative pathing has actually been very beneficial. I have not found a downside to this yet. So I swapped the whole thing over to relative pathing and everything still works very well. So anyways, moving on to how we use the base algorithm. As a parameter, it takes base alg. So what happens is if I instantiate this object without having an implementation for load model and predict, it's gonna throw an exception. So you'll know right away and you'll start failing unit tests if you didn't do that. It has some global objects. It's got an encoder. It's got the clustering algorithm. It's got the anomaly definition, which is that pickle file for which cluster belongs to an anomaly and which one's normal. Telemetry keys, feature keys, and unique features. So one of the first things is trying to locate the path of where this got installed. So when it's pip installed, you don't really know where somebody pip installed it. So what I've done is grab the actual location of the file using this OS path real path, and then joined it with the relative for ML assets anomaly. Now this appears to work multi-platform. I've tried this on Linux, I've tried it on Windows, and it's working for both of those. The Linux flavors I've tried are Ubuntu and Debian. I haven't tried others than that. So this seems to work pretty well. That's something else to be aware of when distributing a package, is that your package is going to get installed. It's going to get installed onto a platform that you may not necessarily know. So it's better to use some of these nice things like path join instead of you trying to do string concatenation. So load model, this is one of the expectations. All this really does is it gets the prefix and it uses Keris's load model capabilities to load the H5 file. We don't actually use the decoder. Remember, we settled on the fact that the encode clustering with the for the bucketing was going to work better. So that's really all we needed. And I got an algorithm that worked fairly well without actually having to include the categorical features. So keeping it quite simple here, all we need is the encoder, the clustering model, the definition for which clusters belong to anomaly versus normal, and the variable keys that we're looking for when dissecting the package. Now, predict does a couple of things. First thing is, I wanted to keep it in line with the domain that this project has. So it's looking for a widget. If you're not making widgets and you're making cakes, or you're making, I don't know, big machinery or whatever you make, put that in there. The expectation is to try to make it easy. So by distributing the package and distributing domain models, I want to be able to accept a domain model in, and I want to push a domain model out. That way everybody knows how to work with it. It's not really complicated. It really simplifies the process. So the first thing I gotta do is make one of these widget classification domain objects, which came from the data models section. So if we look up here, our import statement from data models.widget, we're importing the widget and the widget classification. And that way you can do things like wc dot, and look, we get autocomplete from dict, from JSON is good, you know, all that stuff. Anybody who uses the package will also get autocomplete. So it's just a nice thing to have. So anyways, we pre-process this. So this is where a lot of that code comes in. So check this out though. This looks really, really familiar with the processing code from our Spark cluster. It's figuring out, and it's already figured out the keys. So really what it's doing is it's finding what are my time steps, how many variables do I have in a time step, build me a matrix of that shape, and fill her up. I'm pretty sure I said that word for word in the ML when I was explaining how it does it. The last thing is that we need to do a reshape for the specific algorithm input that we settled on. So in this case, it was it's an LSTM, so it expects number of variables, number of time steps, number of samples. We have 1 sample, 10 time steps, and 5 variables. So once we've pre-processed that into the machine learning happy matrix, we actually can shove that into the encoder. The encoder is going to predict on that, and we're going to get our feature map out. Then we take the feature map, we pass it to the clustering algorithm. It calls predict. It's going to assign that to a cluster. Then if the cluster assignment is equal to anomaly, is good is going to be false, right? It's not good, it's false, it's an anomaly. Else is good is going to be true because it was not within the cluster. It was not assigned to the cluster that is an anomaly, therefore it's good. And then it's good to be able to mark down your classified time, because if you encounter an issue or a bug or some kind of problem, you might want to be able to go back and correlate that with, well, what model was I running? What time was I running that model? What version? What commit? Where was that in the telemetry feed? I want to be able to match that up with a variety of things. I can use it in logging as well. So that's just a nice thing to be able to have access to. So that's kind of the main part of the distributed package. So you've got a source, you got a package name, you've got your various sub modules or sub packages inside of there. And then you've got a variety of tests, I can view these tests. I can run these tests all here. We'll come back and check on this. This is going to take a few minutes. It's nice, super nice to have local testing that matches your build server testing. And then we'll go a little bit through the CI/CD for this because I think it's a little bit more important in this case. To distribute a package, I'm using Azure DevOps, and specifically we're using artifacts. You got to create one of these artifacts. So you'll see that we've already created a feed called AI ACC Quality. Last time I published it was on Monday. Click on it and you get some good information on it. We can grab the files, the wheel files. You can install this version, connect to the feed. Check this out. So upload, and then where was the install? I've got it in a different location. So if I want to install using this package, all tests pass. Let's pull up the web app just so you can see an example of what a requirements TXT would look like leveraging this. So it's index URL for the extra index. It's got a baked in key here because it's a private PyPI. You have to have that key to get access to it. Then it's got all the rest of the information about the location of it. It's a simple index. And once that's added, AI ACC quality, I can now use this requirements TXT and it will install from that index. That's super nice. Additionally, if I just want to install it on my machine, I've got an example install here command. It includes the key, but it's basically a pip install extra index URL with the baked in key. And then you specify the package name and we can upgrade. So check this out. Remember, we uninstalled it earlier. Go ahead and run this. Found it, collecting it, installing it, and all of its dependencies. Pretty sweet. Even things like SciPy. How did we get that? Oh yeah, we should talk about some of these things. So out of the box, when you do packaging, it's not going to include like H5 files and pickle files. You actually have to add those. So setup.py is one of the important things you need to have. You have to have a setup.py. You have to have a setup CFG. You have to have a manifest, a license, and a requirements.txt, I believe. So you can just take this and use this as a template for yourself. The important things here are going to be that I want to find packages inside of the SRC folder. And I also have requirements for TensorFlow, Keras, sklearn. I should probably add things like NumPy. I actually don't think I use pandas, but we'll add it anyways. And pandas. Now, if we take a look at the manifest.in, this is including additional files that need to be in here. So including the readme.md, the license.txt, the star.pkl, and the star.h5. So notice this is SRC, AI, ACC quality, ML, MLSS, anomaly, H5. So when we go up here, we'll see these are H5s and PKLs. Let's check out our pipelines. So when we build, distributed package, edit. One, we're going to install the dependencies required to run the test. We're going to run PyTest. We're going to publish our test results or code coverage. We're going to build this sdist. This sdist is going to place our package files into a new folder, and we need to publish those. So we're going to publish to the SRC distributed package dist folder. Our release pipeline is going to be hooked up to the publishing of those artifacts. So if we go to package distribution and hit edit on this guy, it's out of more. So we're going to install some dependencies. pip and twine. We're going to authenticate with our Python feed. Now this variables, Python feed, AI ACC quality. Now you can actually use Azure Key Vault to hold these as well. So that's a good way to link up between variables, variable groups. We'll dive more into that in the DevOps section. Anyways, we go back in here and upload the private PyPy is we're going to upload that entire dist folder. So if you don't have that manifest.in file specifying that it needs to include those files, when you do a pip install, it's not going to actually include those files. You have to make sure that you specify that those should be included when you build the wheel files. And that's what's going to happen here. So when you do a pip install, it will actually go there. Okay, well, I think that basically concludes the distributed package module, which is module 5. We have a few more modules to go. We'll have to talk about the web application, the data stream, and the DevOps. Thank you very much, and I hope you look forward to more.